In the last video, we saw that quadratic equations can be solved with continued fractions, and you can get better and better approximations by using more and more of those sort of convergence. But the quadratic equations that we were seeing from those were like quadratic equations of the form like that, all of them, and they ended up becoming like that, which then turned into dividing both sides by x, which then turned into. So what we found was a continued fraction. It was not a simple continued fraction because these c's, it could be 1, but usually wasn't. And the answers to those quadratic equations were like kind of complicated. They were like, when you do the quadratic formula with this thing, you would get, b plus the square root of b squared plus 4c over 2a. And this b was always a number. It was never 0. So this expression was, kind of complicated. If you try to make a quadratic, let's say I want to find the square root of 2, and I try to make a quadratic equation, x squared minus 2 equals 0, and I try to do the continued fraction method, divide both sides by x, this happens. You might say, okay, what's the problem with that? Well, the problem with that is when you replace this x with 2 over x, you end up with something like this. It's kind of weird. It does have convergence. The convergence are 2 would be the first one. But the second conversion would be 1, because it would be 2 over 2. And the third one would be back to 2, because it would be 2 over 2 over 2. And it would just alternate between 1 and 2, which would not help us get, we already know that the square root of 2 is between 1 and 2. Well, there are continued fractions for things like the square root of 2, but they're difficult to find. I'm going to do that in another video. But I'm going to show you what the continued fraction for the square root of 2 looks like. So when we look at this, it's interesting. It does have 1s on top, and that's good. That's going to be useful. Well, one thing it's useful for is it allows us, if it's a simple continued fraction with all 1s in the numerator, we can just write the integer part and then all the denominators. And you can see this actually has a nice repeating pattern. You're even allowed to write it like that if you have a repeating pattern. But I want to show you in this video how to calculate this thing out to show that it's equal to the square root of 2. So I'm going to write it again. Now the issue is we don't have like an exact copy of x. See, x is this entire thing. And we don't have in these denominators an exact copy, in other words, a 1 plus. There's no more 1 pluses, there's only 2 pluses from then on. So the trick to this question is to add 1 to both sides, and then this 1 here turns into a 2. And that's good because this thing, this entire expression, 2 plus 1 over 2 plus 1 over, is a smaller version of it, is right over there. So I say x plus 1 equals 2 plus 1 over, and this red square rectangle thing is not x, but it is x plus 1. Okay, the way we continue this question is we get common denominators. So this 2 turns into 2 times x plus 1 over x plus 1 plus 1 over x plus 1, which is 2x plus 2 over x plus 1, plus 1 like that, which is 2x plus 3 over x plus 1. And if you're able to go straight from here to here, that's fine. In your head, you kind of imagine 2 times x plus 1 is 2x plus 2, plus the 1 is 2x plus 3. That's fine. Now we multiply both sides by the denominator, x plus 1, and we get x squared plus 2x plus 1 equals 2x plus 3. And really, really conveniently, if you do this right, the 2x's ends up canceling out. You get x squared equals 3, or x equals 2, sorry, or x equals the square root of 2. Now, it's not easy to come up with this expression. I'll show you that in another video. But if you have the expression already, with being careful, you will be able to see what thing it's the square root of. So here is a practice question for you to do now. Take a few minutes to see if you do it right, it will become the square root of something. If you did it right, you should have ended up with x equals the square root of 5. What you would do to get that is you would first, you notice there's a 4, 4, 4, so we really wish that was a 4. So we add 2 to both sides. Now it is. And then I see this 4 plus 1 over 4 is the same thing as x plus 2. This becomes x plus 2. This becomes 4x plus 8 plus 1, which is 4x plus 9 over x plus 2. So cross multiply. X squared plus 4x. I like that. That means it's going to cancel out with this. Plus 4 equals 4x plus 9. Becomes x squared equals 5. Becomes x equals 5. These can get a little bit harder. Like this one, it goes like this, as 1, and these numbers here are not all the same as they were before. It's alternating. It's 1, 1, 2, 1, and it appears like it would be switching between 1 and 2 like that. You could actually even write this as 1, semicolon, 1, comma 2, and you can put like a bar over that. This one's a little trickier. So the pattern goes 1, 2, 1, 2, except the very first number. It would really be nice if that number was a 2 also, because there is no exact copy of this 1 plus 1 over 1 plus 1 over 1 plus 1 over 2. You don't see that anywhere else, because here we sort of have 2 1s in a row, and then from then on it alternates. So the trick is to add 1 to both sides. So this becomes 2 plus 1 over 1 plus 1 over 2 plus dot dot dot. Now this 2 plus 1 over 1 thing starts over right over here. So this becomes 2 plus 1 over 1 plus 1 over x plus 1. So this has got a lot of layers to it. So at this point, I have x plus 1 equals 2 plus 1 over 1 plus 1 over x plus 1. And this, unfortunately, is going to take a little bit of unpacking. I'm going to work my way from the bottom to the top. So 1 plus 1 over x plus 1 is x plus 2 over x plus 1. Now there's a 1 in the numerator, so we can take the reciprocal of that. So it's 2 plus x plus 1 over x plus 2. Now I can add these together, again with a common denominator. So x plus 2 times 2 is 2x plus 4, so this becomes 3x plus 5 over x plus 2. Now I can cross multiply and I get x squared plus 3x plus 2 equals 3x plus 5. If you do these right, the 3x's should cancel out, and you get x squared equals 3, or x equals radical 3. So that one was more difficult. Okay, here's one for you to do now. If you do it properly, the answer should become x is some like square root. Okay, did you get the square root of 11? I did. Let's see how I would have done that. First I'm going to, notice it's 3, 3, 6. I really wish it was 6, 3, 6, 3. So I'm going to add 3 to both sides. So now it is 6 over 1 over 3 plus 1 over, but here's where the 6 happens for the first time. So I'm going to put the x plus 3 here. Now this 3 plus 1 over x plus 3 is actually 3x plus 10 over x plus 3. But then I'm going to take the reciprocal of that. I'm going to skip a couple of steps here. So I get x plus 3 over 3x plus 10. When I add those things together, I get 19x plus 63 over 3x plus 10, and an x plus 3 over here. When I cross multiply, I get 3x squared plus 19x plus 30 equals 19x plus 63. The 19x cancels out. 3x squared equals 63. Sorry, equals 33. So x squared equals 11. So x equals the square root of 11. And here is the challenge problem of the day. And this is actually a very challenging one. Some square roots have even more layers. So here's the challenge question. So what we see here is 3, 1, 2, 1, and then it becomes 6, 1, 2, 1, and it's going to be 6, 1, 2, 1 from then on. So I'm going to write 3, 1, 2, 1, 6, like that. This one is going to become a nice square root at the end, but which one does it become? This one takes a while, so do your best, and I'll put up the answer afterwards. Well, if you got the square root of 14, you were right. This one is pretty challenging. The first thing I want you to notice is that there's no other 3's. There's only this 3. If this 3 were a 6, that would be better, because then it would be 6 plus 1 over 1 plus 1 over 2 plus 1 over 1 plus 1 over, instead of doing the whole 6 plus, I could put x plus 3 there. So that's a lot of levels. I'm going to work up one level at a time. I'll start with this one. Actually, I'm going to go like that. So 1 plus 1 over x plus 3 is x plus 4 over x plus 3, and then you put 1 over that, and it's x plus 3 over x plus 4. Next, I'm going to work on this piece. 2 is the same thing as 2x plus 8 over x plus 4. So this becomes 3x plus 11 over x plus 4. And then with the 1 on top becomes x plus 4 over 3x plus 11. So now this looks like this. 6 plus 1 over 1 plus x plus 4 over 3x plus 11. Now this thing, 1 becomes 3x plus 11, plus x plus 4 is 4x plus 15 over 3x plus 11, and then the 1 there ends up becoming 3x plus 11 over 4x plus 15. So now I'm looking at x plus 3 equals 6 plus 3x plus 11 over 4x plus 15. And when you add 6, which is the same thing as 24x plus 90, you get 27x plus 101 over 4x plus 15. Now when you cross multiply, we get 4x squared plus 15x plus 12x is plus 27x. That's good, because I have that here also. Plus 45. Subtract the 27x from both sides. Subtract the 45 from both sides. You get 56. 56 divided by 4 is 14. And x is the square root of 14. And there are ones with even more layers than that, but that's certainly a lot of layers for the challenge question.